don't grade on our creativity or the right concept. Is that right?
So for this course, we're just going to do it based on correctness. Did you solve the problem? And style of the code. Is it organized well? If you do want feedback about, I guess what we would call the implementation, you can solve a problem like you might have saw in lecture. If you're going through the phone book, you can solve the problem correctly by going through the phone book one page at a time. But that's not the best design, right? So if you want feedback, feel free to contact me, contact your teaching fellow, and we can, take a look at your code and provide some additional feedback.
All right, that's a great insight. Thank you so much, Josh.
Yep. And then for the Scratch problem, I'll probably just go through and look at some people's just because I like them. They're fun to see.
Okay, good morning,
yeah.
Mr. Josh.
Hi.
I want to ask you some question.
Mm-hmm.
The first one, my teacher fellow is Mr. Guy, and
Okay.
I a little bit difficult to ask him because I'm teaching now, and I see the office hour. That what I want to ask you is, can I ask you? But you are not my teacher fellow.
Yep, that's okay.
Oh, yes.
We're all here with the same goal. So ask anybody that you want with the class.
Because sometimes when I do my assignment, it's not Mr. Guy office hour. So I a little bit difficult to ask him because it's not his office hours. And the second is, I a little bit scared about the problem set 9 in your graphic.
Yes.
Can you give me some advice to do this course and it well?
So I understand that this can be a little bit scary. The good thing about how we're going through this course is that you'll have a little bit of extra time. A lot of our, we don't do this just as like 1 week to the next. I think the first few are back to back, but then there's some problems where we have 2 weeks or so. So you'll have a little bit more time, to work on them. Advice, that's tough. Start as early as you can. That's always good. My other advice, and I think we can talk about this. We can talk about it now. Break down, take the big problem and break it into small pieces. Don't try to solve the whole problem set at once, right? It'll be easier to talk about in a real programming language, but, just get one part to work and then add the next little bit. And that way you can turn this big, overwhelming problem into some smaller, manageable pieces. And if you do that, it feels a little better. But if you're running into difficulties as we go through, I'll talk about this in just a minute, but we do have office hours. Again, reach out on the discussion forum. I know that the time difference makes it a little bit difficult, but we'll do our best to answer you as quickly as possible.
Thank you, sir, for the answer.
Who's up next? Risky?
Okay.
I'm sorry if I'm saying names wrong.
Yes, yes, you're right.
Okay.
Okay. First, I'd like to ask to you about the academic honestly. Uh, uh, what if we we got a problem solution by searching in the Google or in the any search engine? So we 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 like to copy the the solution, not exactly copy it, but if we do modify the solution from the search engine, is that makes academia honestly not
Yeah.
reasonable, or we just cheating like that?
So, I mean, I guess that the official answer is that, according to the policy that like, if
Yeah,
you are searching for the actual solution to the problem, that is not not reasonable. It's, that's cheating.
yeah.
If you are searching for a piece of the problem,
Mhm.
how do I, make a custom function in Scratch?
Yeah.
Perfectly great. Um, the secret to all programmers everywhere is that I'll even consider I'm sometimes a programmer. We go online, we search stuff, we take other people's ideas,
Yeah.
we mix them up, put them together, and that's perfect. That's the real world. So I think that to me is reasonable. When it comes down to it, it's just you know what
Just copy
what you're
paste.
going to get out of it. If you're searching something to improve your understanding, that's great. Um, but it's your class, so you do what feels right to you.
Okay. Okay. Thank you for your advice.
Yeah.
And one more. Can we catch you in email or in to discuss about the study in this class? Maybe problem solving, or maybe labs to discussing that with you in the EDs or in email. Would you prefer to answer that?
Um, contact contact us about anything, any way that you want.
Mhm.
So I guess really that means for me email and the discussion forum.
Yeah.
If you have some other way that you'd like to talk, I'm happy to try it out. But that works.
Okay. Okay. Thank you, Josh.
Yeah. Okay. I'm gonna move on. I think we already talked about some of what I want to talk about, but let's do it again anyway. I just want to point out on the website some general resources that we have available for us. I've been talking about the discussion forum over and over. I think it's a great resource. Office hours are just time that we as staff have set aside that we will be online on Zoom and available. So if you want to talk to an actual person instead of a message board, we'll be here. Um, you don't have to attend any of them. If you're doing fine, that's great. If the discussions work for you, that's great, but it's an option. I think there's a question in the chat about Visual Studio Code and GitHub, and I think we'll go into that more starting next week if I can delay that question a little. Sorry. There's a link here for shorts, and these are brief videos that explain different topics, things that might come up and you might want a little bit more information on. So, we talked about functions. You can actually go in and watch a video where Doug explains in a little bit more detail what functions are, things like that. And the syllabus has tons of answers in it. So that's usually the first place I look for any questions that I have. One thing I do want to point out, and I'm gonna put this because it's easy to miss, and I'm gonna just go over to the actual website for this. There's the video player. This takes up a lot of my screen, but below it there are a bunch of different links. If you want these slides that David uses for some reason during lecture, they're not usually very interesting on their own. You can get them and look at them. I think very usefully, there's a link here for notes. And basically, we have staff that have attended the lectures, watched the lectures, and have taken notes about what's going on. So, if the lecture is moving too fast, feel free to read through these and make sure you understand the main points of the lecture. So that's easy to miss, and I just wanted to point that out. Later, when we have, actually even here, there's source code available for any of the examples that David gives in lecture, so you can take a look at those and see what's happening. So yeah, I just wanted to make sure you were all aware of those. They're very helpful. And then my suggestion, I said earlier, David talks very fast. There's an option on YouTube, if you go down to the settings, the playback speed. I often put him on 3/4, 0.75, slows him down a little bit, makes it a little easier to follow for me. I was playing with this and I saw that I was going to say, turn on subtitles. That helps too. English subtitles are great. They're probably pretty good. I saw that there's an option to actually translate the subtitles. It's a machine doing the translation, so it may not be good, but I'm interested. So if anybody wants to, try out a translation and see how it works, it's an option out there. Sorry, some questions in the chat. Mashuri, we can help with the Ed account offline. I think we can take a look at that. And then asking for project guidance during office hours sounds perfect. That sounds like a great use of time. All right, and as was referred to earlier, I'm saying this is the most important resource out there is the internet. I'm showing Google here, but your search engine of choice. Completely reasonable to ask a question, look at some examples, see how people do it. Later on, when we get to HTML and CSS, I don't remember. I use it so rarely that anytime I use CSS, I have to have a reference in front of me. I just can't do it from my own brain. So I use the internet as my brain and get some information from there. All right, I'll take one more pause for questions, anything before we do a little bit of review from the lecture. Yeah. That should be fine. The only benefit of using VS Code the way we are using it here is that it's already integrated with there's a special CS50 library that we use that makes things a little easier in the first couple weeks. There are some tools built into it to help you check your code and submit your code. So, I mean, during this course, it might be easier to use VS Code. If you want to write in one and copy paste to the other, I think that would be fine too. But we might be able to work something out. I don't know because I actually use Visual Studio Code like on my computer every day. That's my favorite editor. So, sorry, I can't provide a little bit more guidance there. It's not hard to learn. Yeah, it's pretty simple. It's just going to be and I think we'll talk about it more next week. This is going to take forever to load. I can pull up my real copy of this is my real copy of Visual Studio Code. So it's just going to have some file space in there, a text editor, and a terminal down at the bottom, and that's it. So it's pretty simple. Yep. Mm-hmm. Yeah. So this is what Visual Studio Code looks like. I have it in a dark mode. You can also make it light. You can change what it looks like. So we just have a directory structure over here for your files. You open it up in here. This is my hello world, and then I can run it in, and we'll go through this next week. I'm not in the right directory. We'll go through how to use this. So if this is totally strange to you, that's okay. We'll talk about it soon.
We talk about it next week, yeah, Mr.
Yep.
Josh. Okay,
Yes.
next week.
So this will be the first program you all work on. It's just a nice little web-based tool here. If you are not don't have reliable internet, something like that, you can work offline. You can download Visual Studio Code if you'd like. It's free, or you can work in something else and then copy paste over. That's fine too. Yeah, I don't want to get too far ahead and scare people. So don't worry
That's
too much
why.
about that. Yeah.
Honestly, I'm scared because I don't understand anything about this.
Yep.
It's so
this whole thing
unfamiliar for
is,
me. I don't really familiar with these things yet.
It is. You will be soon, and this will all make
Okay.
sense soon.
Slowly.
I promise. I promise
Okay.
this will make sense soon.
Thank you, Mr. Josh.
Just I just try to make hello world like that, but
Mhm.
I have some trouble when I run and debug this. It's just like there is a notice that JSON lab, JSON dot blah 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 something. What's
Yeah, so that
wrong?
might be a good thing to talk about during office hours, or we could maybe make a post on Ed, because we'd have to look at your
Yeah.
code or your environment. So I can't give you a general solution. There is a tool. Now we're getting way ahead. There's a tool called, I'm messing things up. It's called Help50. And this is what I'm saying. We have some built-in tools. And you can actually, let me, I can break,
Oh,
I don't remember how to use this. It's been a long time, and I haven't watched the lectures. I'm a bad teacher. I haven't watched ahead. Yeah. So basically, there's going to be a built-in tool that tells you, if you have some problems with it, like what could be wrong. It helps you interpret error messages, things like that. So that's why I'm saying that this is a nice environment, because it does have these built-in tools that will make your life a little easier, especially if you're new and getting started.
And this is connected with Visual Code Studio with GitHub, right?
Yes.
Okay. Thank you, Josh.
So usually the first thing that we tell people to do when they get into this environment is run a command called, you'll see a theme with all our commands, update 50. And this will actually make sure everything is installed correctly in your environment. So if something went wrong, we can rebuild the whole environment. It does take a while to run, but it might just be that the default version isn't working right.
And this is online. How about offline, Mr. Josh? If we rebuild this?
Offline, you may not have, do you have like a C compiler installed? Things like that. So we'd have to actually look at what your system has and what's happening.
Okay,
so
thank you, Mr. Josh.
Yeah, if you want to stop by somebody's office hours, I think we could probably help.
Yeah.
And also, it does seem like in the chat there's a couple people having problems with grade scope. Just so we can keep moving, and I don't want to take up your whole day. Would you mind just sending me an email? I'm going to put my email in here, and I will take a look at what's going on. All right. So pretty quickly, I'd just like to go through some of the material. Oh, there's another hand up. Yes, Radin.
Mr. Josh, I have tried what you have shown to me, how to use Visual Code Online, but when I click on it, so I see the window notification, the message like this: oh no, we were unable to connect to your code space. Restart and reconnect to code space. So how can I solve this problem?
I don't know without seeing it again. So I think, any problems with this, they're very unique to you and your situation. So it's sort of hard to do without sitting down with you and seeing your screen. So I'm sorry I can't be more helpful right now.
Yeah, because I have tried to access the online VS Code. When I click on the button, so my VS Code Online will not appear that like yours. Always there is the information message for me: we cannot enable to your code space. Restart and reconnect to code space.
Yeah. I don't know what to do with that, honestly, but we could try taking a look at it during office hours. And you do have a little bit of time before we need to be in this. So there actually could be, this is working ahead. There may actually be problems on our end, on CS50's end, that we might not have configured it yet. I don't know if that's true or not. I'm just saying it might not be just you. So we'll figure out what's going on.
Okay, that's okay. Thank you, Josh.
Trang.
Okay, thank you. My name is Trang. I'm from Surabaya, Indonesia. I have two questions for you. Maybe one is simple one. Maybe I missed some information. What this is CS50. What's this of 50 means?
The 50 is just the course number in Harvard's course catalog. So it means nothing. But the course has sort of taken it and adopted it, used it for all sorts of stuff.
Okay.
So it's just them being a little bit silly or trying to have fun. Yeah.
Maybe it's the number of the activities or some kind. Okay, the second question is, if we have installed the Visual Studio Code and then we uninstall it, maybe when we install the Visual Studio Code, we also install MinGW and another application. So my question is, if we uninstall it, is the MinGW also uninstall or?
So I don't think so. I'm not I'm not really familiar. Again, like I haven't
with the Visual Studio Code. Yeah.
Yeah. I would have to again look at what's happening with your specific system. So yeah, somebody said the online VS Code works well. There should be instructions if you can get connected. If you can get connected, it works well. But yeah, there should be some. Next week with the problem set, there should be some instructions. Yeah.
Okay, so maybe we better use the online.
If you can, the online one works. At least for me, it works really well. But if you want to set up an offline version, there may be instructions, or we could work together to set that up.
Okay, thank you. Thank you very much.
Ishsan. I can't hear you. I don't know if it's
your mic, Iksan. We can hear. Your voice is not here.
Yeah.
It's already unmute, but we cannot hear his voice. Maybe you can use the text, the chat box.
Yeah. The wonders of technology. So sorry.
Don't use headset.
Coba pakai.
It's okay.
Pakai speaker biasa.
Pakai speaker biasa, nggak usah pakai headset.
Hello?
Nah.
Yeah. Okay, sip.
Okay.
Don't use headset.
Okay.
Harus ganti headset ya.
Okay. Okay, sir. I have a question. So my question is, after this official course have done, we will get any kind of certificate, isn't it?
I think so. I honestly don't know much about the program that you were all doing, and I want to talk to somebody to learn more about it. But I just got asked to help out with this, so I am a little bit behind. But yes, normally there's some sort of certificate for completion. There's something that we'll have for you.
Okay. Hello.
Yep.
Okay, then I have a curiosity about this course, sir. Maybe someday if any a kind of job fair, or maybe there is what is it? Exhibition. Okay. Exhibition.
Yeah.
Job exhibition. This course may bring us to get any kind of job in Harvard, maybe someday, or what do you think?
It's a good start. It's
okay,
a good start.
sorry.
That's okay.
Thank you.
Yeah, I don't know what we're going to have for that in terms of like resources. We'll put together some things for sort of like after the course. Here's some resources, some things you might want to think about. But yeah, sorry, I'm just just getting started. I didn't learn I'd be doing this course until last week, so I'm a little behind. I'm sorry.
Okay, sir.
Yeah.
Okay, thank you for the information.
Yep. Okay, so I'm gonna go through this, just some of the review stuff on binary, different topics here. And again, feel free to stop me. I have a couple slides that may go into a little more depth, than lecture, but we can just go through those pretty quickly. And there's a scratch question, but hang on to that, and we'll try to tackle that at the end. I'm sorry. So I think with binary, it's just a different way of counting. I know it can feel very confusing, but you can almost practice using your hand, and using it like the light switches in the lecture, right? So it turns out that using just one hand, you can count all the way to 31. You can start. It takes some gymnastics with your hand for some of the numbers, but you can actually say, this is 0, this is 1. I'm so happy that I found all the emoji to match the lecture. This could be 2, 3. I don't know if you all can see me. 3 with your thumb and forefinger. 4, middle finger, a bit of a rude gesture in the US, but that's okay. And so on and so forth. So it's a fun way to think about this. It's the same idea as base 10, and just in this base 2, we don't have ones, tens, hundreds. We have 1s, 2s, 4s, 8s, and 16s. And just sort of preemptively, I know some people struggle with this. After this week, we probably won't have to think about binary very much. So that's a nice part of abstraction that we're going to talk about. I'm going to skip over this now, but I'm going to actually just let me put this back in here. If you want to look at my slides later, and that the link is here, there's a link to the slides. There's actually some really interesting stuff with binary. We talked about counting in binary, but there's other ideas. We have to represent not just positive numbers above 0, but negative numbers below 0 to do math. And there's actually a few different ways to represent them that people have invented. There's, instead of just integers, counting numbers 1, 2, 3, we have real numbers like fractions and decimals. And we have to represent those using 1s and 0s too. So I thought this was an interesting thing to read, but I'll leave that to you. So building on binary, we talked about ways to represent text. And one of the earliest historical ways to represent text is called ASCII. It is very English-centric, so I apologize to the world for Americans in general. But the idea here is that every character is represented with, it's technically 7 bits, not 8, but that's not a nice number, so we pad it out and we use 8 bits to represent each character. So we talked about in lecture, the capital A is actually represented by the decimal number 65. This is a different number system called hexadecimal, and I talk about that very briefly. This is one called octal, all that stuff. But in the end, whatever your number system is, your computer has to understand binary. So this is what it looks like, underneath the hood to your computer. The people who did this were actually a little bit clever, and I didn't understand this at first. Why you have A through Z, and then you have a couple extra characters, and then you have lowercase letters. 65 for A, but 97 for a small a. And it turns out that the difference between an uppercase, a big character, and a lowercase character is actually just this position, right here. And that a 0 here means it's uppercase, and a 1 here means it's lowercase. So same thing with the letter U, 1 0 1 0 1 0 1. It was just fun to type, so that's why I picked it. And then the lowercase one just differs at this position. And this, when I heard this, this was something that really struck me. I don't know if you've ever seen on a computer where it tries to sort maybe file names or something, and all of the uppercase letters come first, and then all of the lowercase letters come later on. And that's because when your computer is trying to put files in order or things like that, it's actually seeing the number that's behind it. So alphabetically, even though a Z comes way at the end of the alphabet, an uppercase Z could be smaller numerically than lowercase a 90 versus 97. So that's just a fun thing that I was like, why are computers broken? It turns out they're not broken. They're just treating these as numbers. Turns out that there is an entire world outside of America. So we need to go beyond those standard English characters and, represent the languages of the world and all sorts of other crazy things. So, in ASCII, we really only have enough bits to represent 256 characters. There's a lot more out there. So thankfully, at least nowadays, memory, the hardware is relatively inexpensive. I'm saying it's still expensive, but per amount of memory that you have, it's getting cheaper and cheaper. So it's okay to use a few more bits to represent different characters. So Unicode, you might see there's a specific type of Unicode implementation called UTF-8. This is the most common way that text is represented in the world right now. I think it's 99% of applications. And in here, instead of just using 1 byte per character, we can actually use between 1 to 4 bytes per character. And I'm saying character here, but that's not entirely true. There's a specific term here called a code point. That's basically a piece of a character, but that's maybe a little too much detail for most things. So, if you want to get into it, it turns out that multiple code points can be put together and make compound symbols. So one of the examples we talked about emoji, but something like flag emojis here aren't just actually 1 character. So behind the scenes, they are represented. This is a fancy way of this U plus means it's Unicode. And this is a hexadecimal number. Don't worry too much about it. But these 2 characters together actually make up the flag emoji shown here. So if you want to look at this, this is what those things look like in binary, all of that put together for one little picture. Or in decimal, it's the same numbers here. So it's a really cool idea. We can use some extra bytes here, and then we can actually start putting all of these combinations of code points together and get all sorts of different symbols, emojis, those compound emojis that David was showing in lecture, where you have like 2 people and a heart, and that's actually 3 separate emojis all squished together. So it's really cool. I think one of the last lectures we have will be on emoji, and in the past we've seen one. We've had a person in from the Unicode consortium, and she is one of the people that actually decides what new emojis are going to get released every year. So I thought it might be something fun to look forward to. So beyond text, we use computers for lots of other things. So let's talk about images. So this is Harvard's crest here. And really, if we take a look at this, all of those images are made up of little tiny pixels. And every little pixel has some amount of color to it. So because my program knows this is an image, it can take these binary values and interpret them as different colors. So Harvard crimson is a specific color. Harvard has guidelines on what it should look like. And, it's a lot of red, no green, and just a touch of blue. We talked about using a scale of 0 to 255. This is the range that you can express with 1 byte of memory. So this is what it looks like in binary. I've referred to hexadecimal a couple times. I'll talk about it right now. Again, if it's just too much for you, don't worry about it. We won't have to deal with it for a bit. But hexadecimal is just a nice way to take these very long binary strings and make them a little shorter, make them a little, more friendly to show up on your screen. So just going to go through this. Hexadecimal is just a different counting system. So we talked about unary, like counting on your fingers, 1, 2, 3. We talked about binary, where everything is powers of 2, decimal, where everything is powers of 10. Hexadecimal is everything is powers of 16. So basically, we have a bit that we talked about that's a 0 or 1. Have this idea of a byte that is 8 bits, and that's 0 to 255. And 16 works very nicely with this powers of 2. If you take a number, this binary representation of 255, and kind of cut it in half. Each side is a power of 16. So this is 1 plus 2 plus 4 plus 8, so that's 15. And 1 plus 2 plus 4 plus 8, 15. And we can say this is 15 times 16 to the 0, so that's just 15, and this is actually 15 times 16 over here. That's nice. So when we're counting in decimal, we see 0, 1, 2, 3, 4. We go 5, 6, 7, 8, 9. And in decimal, the next number would be 10, but we can't use 10 anymore because now that's 2 characters. And, that's a specific thing to a decimal representation. So somebody made a smart idea to start using letters after that, and that's what you'll see here. So if counting in hexadecimal goes 8, 9, A, B, C, D, E, F for 10, 11, 12, 13, 14, 15. And that's what lets you take this, string of 8 ones and compress it down to 2 characters there of just FF. We might get into this much later in the semester when we're doing some stuff. This, as I sort of showed, actually I can keep going forward. As I showed here, its hexadecimal notation is often used for things like color, if you're doing graphic design or websites, things like that. So we'll maybe come back to that. But all of this sort of gets to abstraction, right? So we start from ones and zeros or hexadecimal. I don't want to worry about that anymore, right? I just want a picture. So all of these numbers make up 1 pixel in my image. That 1 pixel gets put together with a whole bunch of other pixels to make a piece of an image, and then that, goes together and creates this whole thing. And it's really good to know about the binary behind it, but at the end of the day, I care about the picture, and I trust that somebody else that's much more interested in the lower level details than I am has taken care of this. And that's the whole concept behind abstraction. So we're going to start, and we have very much started from the bottom up with binary, but as we progress further in the course, we'll move away from this and just worry about what we want to do instead of how all of it is really built. Yeah. Algorithms, something we talked about here. It's a very fancy word. It's a, we call a buzzword in English. It's something that companies use to make themselves sound fancy. All it is just a series of steps that you do to accomplish some task. So if you are following a recipe, that is an algorithm to bake a cake. If you're taking a bookshelf and putting it in alphabetical order, if you're grading papers, and I used to do this as a teaching assistant when I had a 400-person chemistry class, we'd have to grade all the papers and then put them all in alphabetical order so that people could input them into the system. You're following an algorithm there. Pick up a paper, look at the last name, look at the letter of the last name, put it in the right pile. Driving directions on Google Maps. So these are all examples of algorithms. The major difference between me baking a cake and a computer doing something is that computers don't have any room for ambiguity, for interpretation. They do exactly what they're told. So computers are very dumb. They are very good at doing very simple things really, really fast. So that's what we have to remember when we're writing programs, is that we have to be very careful to tell the computer to do exactly what we want to do. We talked very briefly about algorithmic complexity. We'll come back to this in lecture 3, but this is, the phone book search where we had a linear complexity and then the divide and conquer, tear it in half. Everybody always loves the tearing the phone book. That is logarithmic. And so as the problem gets bigger and bigger, it doesn't get worse in time. And so we'll cover this in lecture 3 in some more detail and talk about why it's important and how you might want to optimize your code thinking about this. And the very last thing, sorry, I'm moving quickly. I want to try to wrap up. We talked about is pseudocode. This is very simple. I saw a lot of English teachers out there. My English teachers always taught me before I wrote an essay to get my thoughts together, to write an outline, to put all the steps in order. And then once you have all of that planned out, you can go in and fill in the details. So that's exactly what pseudocode is. You just write out your steps for what you want to do in, I'm going to say, I do it in English, obviously. Write it in whatever you want. And then I still do this when I write programs. If it's not something very simple, I always do this. It takes a couple extra minutes and it makes me get my thoughts together. I write it out. We'll talk about comments in codes later. And then I sort of fill in my outline. So, I hope you'll have the opportunity to practice with some pseudocode before we write the real stuff. And then Scratch. We don't have much time to go through this. The lecture is a good resource. I've gotten a few people asking questions about looking at or using other projects. And I'm saying here that it's absolutely acceptable to use them for ideas or inspiration, but try not to just take somebody else's program and copy, then paste it into your own. And questions. I see there's been some questions in the chat about Scratch. And I will confess I am not an expert at all. I use it for 1 week every year and then forget about it. So are there still questions? I know some people were trying to help answer them. Anything I can try to tackle about Scratch? While you're thinking about that, again, some people had grade scope problems. Do email. That would be helpful. Email me because we need to make sure you have access to it. When you submit your Scratch project, make sure you download it and make sure that file ends in SB3. And then you should be able to upload it. And it may take a couple minutes, but there'll actually be feedback that says, if your project meets the requirements. A couple people have posted about having problems saving their project online. If you've uploaded something large, a large sound or a large image, or if you've gone crazy in your project and made it very involved, you may not be able to save it online. So the only solution, unfortunately, is just to download the file. So somebody said, can we recreate something? I think that's reasonable. I might try to put your own influence on your own, spin on things, make it your own a little bit. And it's okay that you don't have experience with it. It doesn't have to be, okay, we're not looking for anything that's as complex as some of the examples in lecture, right? That's a lot of work. So, it doesn't have to be that involved. And another question about custom blocks. Yeah, if you create a custom block in one project, I guess it can be used in another. I don't know if you can use it across the project. I think you would have to just copy it from one project to the other, unfortunately. I don't know that the projects can see each other. So I think you'd have to re-implement it. Other issues, anything people are seeing? And again, if you don't want to talk now, office hours are great. The discussion forum is great. Yeah, so the perfect score is not going to be terribly hard to get. As somebody says, we're looking for a perfect score. It's just a checklist. Does it meet all the requirements? So that's it. You could get, a perfect score with, something simple. You could get a perfect score with something very complicated. And, it's just up to you what you want to do. Yeah, so somebody's asking about creating custom blocks in Scratch. Just go to so there's some examples in lecture, but we can make our own block to do stuff. We can put that all together. We can also wow, it's been a while since I've used this. What do I want to do? So yeah, my blocks here, make a block. I'm horrible at this. I haven't actually done this in probably 2 years. So this would, make your own block. I called it test here. I could say, I want something to, I'm going to steal this. Every time I, do this, I'm going to have the cat move 10 steps and say meow. This is not very original. I'm not doing much anything here. But then I can go into my blocks and, pop this in and just use it as a shortcut. This isn't a very good example because if I'm just doing this, it's probably easier just to put these two right in here. But if I want him to do something, crazier or, I want him to do a whole sequence of moves and turns or something like that, and I'm going to have them do it multiple times, then I think this makes sense. So I can click this and it's not going to do anything. I'm just waiting for me to press the space key. So if I push the space key, it's moving. slowly but surely up and to the right. So that's the idea just behind custom things. You can define them once somewhere. It doesn't have to be on the sprite. It could be on the backdrop or wherever, and then use it throughout the rest of your, I guess, I thought you could use it throughout everything. See, I'm learning stuff too. It looks like you have to define it within the scope of where you're going to use it. So in the sprite or on the backdrop. I thought it carried through. Yeah, so somebody said it's useful for repetition, so you don't write the same thing over and over again. You'll see that once we move to a real programming language. That's when if you're copying and pasting the same lines of code over and over again in a program, that's a good sign that maybe it's time to factor them out. We call it like pull it out, turn it into its own function, and just make it reusable. So that's a big part of defining functions, is that reusability. All right, I think we're coming up on the official time. So I'm usually how I end my section. When I'm done, often they don't go this whole time. We covered a whole bunch of stuff about the course. I'm going to let you go. I will hang around as long as you would like to, just talk, to answer questions, to help out. I have nowhere to be. It's night for me, so I'm sure you all have stuff to get to though. But thank you so much for tuning in. I hope to see you again. If not, that's okay too. Maybe go try some other sections out. And yeah, thanks so much. Have a great day, and good luck with the problem set.
Thank you, Josh.
Thank you,
Thank you,
Mr.
Mr.
Josh.
Thank you.
Thank you, Mr. Josh.
Thank you, sir.
See you again next
How
week.
much you?
Thank you, Mr. Josh.
Nice to meet you.
Udah selesai ya? Aduh, kok cepet amat.
All right, so Cindy said,
Thank you.
So quickly. I need more.
So quick.
One
You can go to
question. So
this hour,
somebody
madam.
had a question about where should you put the custom block that will call for more than one sprite. So it looks like, and I didn't know this, it looks like you'll actually have to copy the whole thing and then paste it over into the other, basically redo it in the other sprite. I thought you could actually do it in one and then reuse it in all of them, but I guess I was mistaken. So unfortunately, Scratch is not the ideal programming language, right? So
Yeah, see.
all right. Yep. Take care of people who are heading out. That's great. Trang, what's
Joshua, can I call you Joshua or Mr. Joshua?
Joshua is fine.
Yeah.
I'm sorry, we're not as formal here in the States. I'm sorry that I'm not being
Okay.
very formal.
I just want to know if we can get maybe some PowerPoint from you.
Yes.
What you have
So
talked.
the link, I'll post it again just so it's at the bottom of the chat right now.
Mm-hmm.
Hang on. So if you go here into week 0, you can click on this slides link and it'll take you to the slides I'm showing here.
Okay, thank you very much.
I'll always have that available.
Yeah. Great. Okay, thank you. Thanks a lot.
Sure thing.
Yeah. You give me some more information about this. Thank you.
Yeah, thank you all. It's been great to have you.
Terus, bye-bye.
Anything else you want to chat? We don't have to just sit here. We're done. We don't have to just sit here and look at each other. So if there's nothing else,
Okay, so
I'm just,
the class dismissed.
you're all dismissed. Yes, but
Okay,
I'll again, if you have questions or want to talk, I'm happy to stay.
Just maybe next meeting we should to record our meeting.
So I was actually just looking at this, and I don't know why it wasn't recording. It's supposed to. So normally it records automatically. I will. I can't change that for Zoom, but I will let the people who can know, because normally we do record and then post the recordings. So I'm sorry about that. I didn't think about that till just now.
For this section, Josh.
I'm sorry?
Admin for the Zoom.
I am, but we need, it's a little bit weird. We share this across all of the teaching fellows, so we need somebody to record it instead of,
No, I think you just be admin for this course. Apa sih? Yang itu lo jadiin admin di Zoom ini kan ada.
Host.
Oh, host, to be host. Sorry, to be host in this
so
Zoom.
Yes, I am a host, so I could have recorded this, but it would. I think it's set up that it would just record to my computer and not the cloud where it needs to be, so that the staff can post the videos. So I just need somebody else to handle it. I need it. Yeah. Yeah, we will. I'll make sure we're recording going forward. And you record. I don't know. I don't think it's enabled. But normally we will have it recorded and we will post them within a day or two. They'll be online and available for you. Have fun. Yeah, sure.
Yeah. Okay. It's allowed.
We're going to record it
us,
anyway.
yeah.
So yeah, that's fine. Absolutely. Yeah.
Sip. Mantap, Mr. Almansyah.
On Rizka.
Yes. Thank you, Bapak Ibu. I'm so sorry. I'm still a new beginner, and I think my questions is like a zero based on this concept. So when we're talking about logical thinking, it's like if, then, and so on and so forth. It's like when I try to implement this on Scratch and I try to make a Saido code, I still got big questions on that. So I just want to know, how can I improve my logical ways of thinking, as well as there's a questions that I asked to fellow students in here. Shall we remember all the code and step by step how to count the letters one by one and retranslate of binary code and stuff like that?
No, don't memorize anything. That's my advice. So I did so poorly in classes where I had to memorize things. What we want you to learn is the concept, the ideas behind this. If it's the details about how to write a loop or how to write conditional statements, we have the internet. We have this amazing resource out there, right? Go look it up. The concept is what's important. We'll work in C and explore some of those concepts. You'll see the same concepts again in Python or in JavaScript. And hopefully when you're done, you'll be comfortable enough that if someone said you have to use some other brand new programming language, you'll be like, well, that's unfortunate, but I'll be able to learn. That it'll take me, a little bit to work out the curly braces and semicolons or whatever, but I know the principles. Yeah.
Talking about pseudocode. Yes.
Yeah.
Yeah. Can you explain more on this?
Sure. the idea, and I'm actually going to go to, I'm going to go to like real stuff I'm working on. So this is like real stuff I'm working on for work. And I started doing this. All of this is Python code. Don't worry about it. But I started by outlining what I wanted to do. So I'm basically looking at databases online and just trying to get information from them and process it. So before I did anything, I went and wrote out sort of what the steps are. Get all of this information from the database. Then once I have all of the information, filter it to the ones that I want. And then, once I filtered it, look at more information to get this. So I wrote out, just in English here, I wrote out the steps of trying to solve the problem I wanted to solve. And then once I had that's pseudocode. Then once I did that, I sort of just filled in the actual code underneath it. So your stuff won't be that complicated, hopefully. It's not that scary. It's just something I had open right now. But, you'll see it in the lecture slides. It's maybe a friendlier example of, wow, there's a lot of slides here. Yeah. No, please do leave. Don't feel like somebody's apologizing for leaving. Please don't apologize. This is extra. We don't, I know you all have jobs and lives. So this is pseudocode, right? So pick up the phone book, open to the middle. It's just writing it out in sort of simple language. The idea is not to use very complex language. You can just use it as simple as possible. And then after that, we can turn this into code. But it's just write out the steps of a problem. You could think about pseudocode is just if you were to give a friend directions how to get to your house. That's pseudocode,
like procedural text on step by step. Is that like that?
Yeah. So it's just, if you wanted to give somebody directions to your house, that's the concept of like, go to this street, turn left, go this far, turn right. Then it's up to them to actually follow the steps, right? You're just sort of giving the idea there.
But so we use the if, what is it? Like if this, then that, like we don't really use that, like when if you are facing what is it, ganggutu, a block, then you do this like that.
Yeah. I mean, you just have to remember that computers are for as smart as they look, computers are very simple. They just do lots of simple things very fast, and that builds up to complexity. So we have to tell them very simply, like, you don't have to tell a friend if you're giving directions, like, if there's, someone in the street, don't drive into them, right? Like, but, now that we're doing things like designing cars that can drive themselves, somebody did have to teach the car to not run into people, right? Like it's very, like, computers do exactly what you tell them. It's not a person who can add their own ideas, right? So.
And when we write the pseudocode, more detail is good. Yeah, Mr. Josh.
It can be. I don't. It's all, what helps you. So pseudocode is usually going to be used for yourself, either to like sort of plan a project, or if you're working in groups. Say if you were working in, like, maybe you don't want to change careers now, but if you are working in, a tech company and you had to plan out how to solve a problem with your team, you might go to the whiteboard, and sit there and write it out together and try to plan it. you don't want to worry about writing code. You just sort of want to figure out how to solve the problem.
Yeah.
Yeah.
Okay.
Thank you.
Yeah.
But later on, will us gonna implement the code like binary, unary stuff on our code for the next? Maaf ya Bapak Ibu ya, maaf.
We will never think about binary. That's not entirely true. We'll there may be times when it comes up a little bit, but you will never have to write binary, convert binary. Anytime I have to do it for a course, I literally go here and go binary to decimal converter, and I go to a website and I plug it in. Right?
Yeah.
Like,
Oh.
I'm okay at math. I'm not great at math, but like I can do it if I have to. I can, in my head, but I'd rather use my limited brain power to do something slightly more interesting. Right. All right. All right. If there's nothing else, I'm going to jump off and try to finish up my day while you get yours started.
Yeah. Okay.
Yeah. Thank you all so much. It's great to see you all.
Okay.
Okay, thank you.
Thank you, Mr. Josh.
Bye.
Bye.
Thank you.
Bye.
See you. Bye-bye.